All right. If you take a look at what I gave you, like I said, what we are doing is essentially the same thing, even though we're now technically in a new section. We're essentially still using trig identities, still working our way through that, still practicing. Good news is there's really not any new strategies or anything that I need to talk to you about. One quick question, the one extra thing we added in yesterday. How do you know when to use the conjugate in a trig identity problem? When there are two terms in the denominator. Whenever you've got a binomial in the denominator, you multiply by its conjugate, which then turns it into a difference of squares, which is usually a trig identity. Okay? So a binomial in the denominator is the key part for that. So if you take a look, this is what's at the top of the sheet on your examples. These are just some guidelines, just some things to think about as you're working with trig identities. A lot of these we've already talked about, but now it's in writing. Okay? One quick thing, by the way, if you take a look, if you take a look at like the first example, here's an example of a trig identity, verifying versus simplifying. What you're taking a look at now in this example, they're telling you the answer. It's right here. They want you to say, all right, here's what you're starting with. You work your way through the process and show me that in the end it equals sine squared. It's the only difference between what we've been doing and what we're now doing. Okay? Which, like I said, by me giving you the answers previously anyway, kind of the same thing. They're just not on a separate sheet. Okay? But when you do an identity or when you do these types of problems, first thing, work only on one side of the equation. Okay? Don't try to do a little bit to one side and a little bit to the other side. Work on the one side of the equation and try to get it to equal the other side. Okay? And usually, it's better to work on the more difficult side, because it's always easier to take something that's difficult and simplify it than it is to take something simple and make it more difficult. Okay? It's always easier to go that route. So the first step you'll do on every one of these problems will be determine which side's the more difficult side and then work on that one. Okay? Number two, if you take a look, this is what we've been talking about the last few days. Look for opportunities to factor, add fractions, so common denominator, square a binomial, create a monomial, algebra. I've been talking about you got to see the algebra. That's basically step two. Number three, look for opportunities to use fundamental identities. You're now starting to get familiar with some of these identities. So look for those opportunities of, I think that's an identity. Let me make a substitution. Okay? Number four, if the preceding guidelines do not help, try converting everything to sines and cosines. We've talked about that. Okay? That's always an option. And last one, which we kind of talked about yesterday a little bit. Don't just sit there and stare at the problem. Okay? Try something. There's 100 different ways to do all of these. So try something and just start working your way through it and see where it takes you. Okay? Don't be afraid to make a mistake. Okay? All right. Let's go into the first one here. Let's take a look. First question on the very first problem. Which one's the more difficult side? I was going to say, it should be fairly obvious on this one. So we're going to work on the left-hand side and try to get it to equal sine squared. So, what do you think? Where do we start this one? What would you do first? What is it? My hope is you're starting to recognize the top is really just tangent squared. That's in one of your Pythagorean identities. Secant squared minus 1 is tangent squared. So we're going to start there. Oops, I do not want to go in red. Okay, so there's step one. Now what? We made a substitution. What would you do next? Okay? There's a lot of things you could do. But the first one that I heard was change the denominator. At this point, and here's how you can use it. One of the things that's nice about the verifying part of the thing. Use the answer to your advantage. Meaning, you're trying to get to sine squared. So at some point, we don't even have sine squared in our problem. At some point, we're going to have to go through and switch these things. Now's as good a time as any. Okay? So let's convert all of this stuff to sines and cosines so that hopefully I can start making it to sine squared. Okay? So tangent squared is sine squared x over cosine squared x over secant squared is 1 over cosine squared. Okay. And so now, anytime we divide by a fraction, same thing as? Yep. So rather than take the numerator and divide, we're going to take the numerator and multiply by the reciprocal of the denominator. Well, isn't that nice? Look what happens. Cosine squared cancels out. There it is. Made it. Sine squared is the answer. Okay? You end up with sine squared over 1, which this is exactly what we were trying to get to. Okay? Let me stop for a second. Questions? Anything not make sense? This is one way to do it. This is not by any means the only way. All right, let's do another one. So in this case, what do you think? What do we do? Yep. So you have this one. Two of the things we've talked about comes into play. Number one, if I'm going to add these fractions together, I have to have a common denominator, which also just happens to be that the denominators are conjugates of each other. So we're going to multiply the first fraction by 1 plus sine of x. We're going to multiply the second fraction by 1 minus the sine of x. And notice again, what we're trying to get to is 2 secant squared, okay? So just keep that in mind as you work your way through that. That's the end result. All right, so first fraction. And I'm going to do a kind of 2 steps in one right now just so that we don't have to keep writing everything down. Numerator for the first one is just 1 plus sine x. Numerator for the second one, 1 minus sine x. I'm going to combine these two fractions into one along with everything else right away. So 1 minus the sine of x. So there's our numerator. If I'm going to multiply out the denominators, what would I get? Close, other way around. Because the 1 is first. 1 minus sine squared. Yep. Okay? Because what we have is a difference of squares now. Just because it's what comes, in this case, it doesn't have to, but you got to be careful with the signs then. Okay? So you could write it as negative sine squared plus 1, but you just be careful. I would say if the 1 comes first, just leave it first. Okay? But what we have is a difference of squares now. So whatever's in the first spot of your factors gets squared. Whatever's in the second spot of the two factors gets squared, and it's always a difference of those two. So if we take a look, first spot is 1. Second spot is sine, so that's going to be sine squared, and that's a difference of the two. Okay? If you FOILed those things out, that's what you'd end up with. All right, let's keep going. So now we can clean this stuff up a little. Again, I'm going to do a couple steps in one here. If we just work on the numerator, I've got 4 different terms. We've got 1 plus 1. Well, that gives me 2. I've got sine of x. I've got negative sine of x. Those cancel. And in the denominator, what do I have? 1 minus sine squared is a trig identity. It is cosine squared. Okay. Cosine squared x. And therefore, if 1 over cosine squared is what? Secant squared. So 2 over cosine squared is 2 secant squared. Okay? You didn't get that part? Okay, let me show you. So if I take that 2 and bring it out front, I'm going to rewrite this as 2 times 1 over cosine squared. That's the same thing. And 1 over cosine squared is secant squared. And so now, that is exactly what we were looking for. 2 times the secant squared x. And there's our answer. How are we doing, okay?
Yep.
Let's do 2 more. And then I'm going to give you time to work from there. Let's do the next one. All right. Again, it's fairly obvious, I would say, that which side is the more difficult side, the side you want to work on. What's one option? Because again, there's multiple options. Yeah, we could multiply that out, and I think that's what most people would do. Kayla, why not? The other thing, if you don't rush it, if you look carefully, both of these in parentheses are identities. We can make substitutions for both to simplify this a little bit. If you FOILed this out, it's not wrong. You'll still get eventually to negative tangent squared. But I would go with the identities because I think you're going to get there quicker. Okay? So in this case, tangent squared plus 1 is really just what? Yep, that's just secant squared. Times cosine squared minus 1. Be careful. Negative sine squared. Oh, look, that's where the negative's coming from. We needed a negative tangent squared. There's the negative. We got it. Now what do we do? Sines and cosines, yep. We end up with 1 over cosine squared x. And then we have a negative sine squared x, which is over 1, technically, yep. And when I multiply those, we get negative sine squared x over cosine squared x, otherwise known as negative tangent squared x. There it is. Do you not find that satisfying when you get to the end? And I was going to say, I find that quite satisfying. When you get to the end, there it is. All right, let's do one more. Let's go with, yeah, let's do 5. Let's do 5. Okay. That's one of the reasons why I picked 5. All right, so if we take a look at this one. First question already came up. Which side do we work with? The harder side. This one's a little bit more difficult to figure out which one is the harder side. So if you're not quite sure, just pick a side and start working on it. Okay? Sometimes it's obvious, sometimes it's not. Okay? Here's what I would say. This is my opinion. Anytime you're dealing with fractions, a lot of times that's more difficult than not. So I would work on the right-hand side on this one. Okay? You don't have to. You can work on the left and go to the right. I'm going to work on the right-hand side also because there's specifically something in this problem I wanted to revisit. If I'm working on the right-hand side, what do I do first? That's what I wanted to revisit. There's a binomial in the denominator. This is a conjugate problem. That's the giveaway that this is a conjugate problem. Okay? There's your binomial. So we're going to multiply by 1 plus the sine of x. Nope. You only work on one side. One side of the equation. All right. So now if we go through and we work our way through this, one of two things, and sometimes it works, sometimes it doesn't. Here's what I mean. Sometimes you want to distribute the cosine, sometimes you don't. You want to just leave it in factored form. And there's not really a great way to know when to do it versus not. I'm going to start by leaving it alone. I'm going to leave it as cosine of x times the quantity 1 plus the sine of x. Okay? If I eventually have to distribute, I will. But for now, I'm going to just leave it alone. When we multiply out the denominator, what would you get? Yeah. So again, just like the last one, it's a difference of squares. First thing squared, 1 squared is 1. Sine squared is just that, sine squared x, and there's a difference between the two. Okay. Which, what's the denominator now equal? What is it? Cosine squared. 1 minus sine squared is cosine squared. Okay. So, now what can I do? Now I can cancel. So in this case, it was the right call to not distribute the cosine.
Where'd you get cosine from?
This one?
No, the bottom.
1 minus sine squared is cosine squared. What's one of your identities?
Cross the cosine and the cosine squared out?
Now you can, and here's why. Because these are multiplied, so you can cancel factors. If this was like 1 plus the cosine, I couldn't cancel the cosines then. It's because it's multiplied, not added or subtracted. You can always cancel factors. You cannot cancel a term. Okay? For example, let me give you just something completely different for a second. If I had, let's say, x plus 4 divided by 4. Look at this for a second, so that you understand this. When you can cancel versus can't. Can I cancel the 4s? Because that's a term. That's not a factor. I can't just go through and say, oh, the 4s go away. The answer is x. Which is why, if this was 1 plus the cosine, I couldn't just cancel cosines. But if I had this, 4 times x divided by 4, can I cancel the 4s? That's what this is. That's why you can cancel the cosines. Because you're multiplying, not adding. Okay? So just as a heads up. All right, so I can cancel. That cosine cancels out one of the cosines in the denominator. I'm going to come up over here now just because I'm running out of room. I don't want to keep going down. Almost there. Okay, so notice what we're trying to get. Here's the last thing. You haven't done a lot of this, so I want to make sure you understand. We are 1 step away from finishing this. When you divide by something, if you remember back when we did complex numbers, we had said you can split a fraction into 2 parts. I can divide each of those by cosine. 1 over cosine x, divide that part, plus sine over cosine. Which? Secant, tangent. There's your answer. Okay? So when you are dividing by one thing, that's why in those directions, if you remember where it talked about a monomial denominator, this is what they were talking about. Get this to one term so that then you can split the fraction into 2 parts. Okay? Do you need me to show you again why that works? No? All right. So, a couple things for today. Obviously, keep working your way through if you're still working on some previous assignments. Remember, yesterday I only gave you the odds. Okay? Hopefully you didn't do all of them. I only gave you the odds yesterday. Today, the worksheet that I have that's similar to this is there's 10 questions on it. I only want you to do the first 7. Okay? I'm going to have you cross off the last 3. Cross off problems 8, 9, and 10. I want you to focus on the first 7. And the rest of the time you'll have to work. Okay?